Shall I start?
Yes, sir.
Yes, sir.
Hello? I'm audible, right?
Yes,
Yes,
sir.
Okay, fine. Yeah. Good evening, all. After a great festive mood of Diwali, um, we, on behalf of Indian Concrete Institute, Mangaluru Center members, and on behalf of QCrete Concrete, that is Ready Mix Concrete and Private Limited, jointly we are bringing this program for you. This is the webinar series number 44, and it's my privilege to welcome you all to this 44th webinar meeting. And with this, actually, I'm also glad that I'm going to welcome the speaker for the day, my own colleague, and I can say my guru from the days of Ambuja Cements and till now. So none other than the one and only Shelly Fernandez, who has been a great mentor, tutor for not only me, many of us who have worked under him. And today's session is going to be very interesting, and I wish all the attendees a great session. And at the same time, I would love to welcome all the officials from QCrete and my dear Kaushika sir, who is the moderator for this program. Thank you, one and all. Enjoy the talk by engineer Shelly Fernandez. Thank you so much. Back to you, Kaushika sir.
Good evening. On behalf of QCrete Remix India Private Limited, I am welcoming Shelly Fernandez sir, who is also MD of QCrete Remix Private Limited, and it is really a great day for us because after it has taken us now 44th webinar. Okay, so Mr. Shelly Fernandez is speaking today, and I'll just briefly introduce Mr. Shelly Fernandez. I know him from 2007, and we were colleagues in RMC, and that was probably my privilege to have worked, and I know him from last 13-14 years. Shelly Fernandez, he graduated from MIT Manipal 1984, Mysore University, and he did a postgraduate program in concrete technology and construction from Institute of Concrete Technology, UK. Most importantly, he's a veteran. He has 30 plus years of experience in construction, execution, management of roads, bridges, residential buildings, cement, ready-mix concrete, etc. And most importantly, each of the mentioned structures he knows in and out, from execution, planning until QAQC management, all aspects of civil engineering. And just to read out, because it is a we are short of time, but just I will read out the career milestones or important points. He has implemented mixed designs in many places, and most importantly, he has taught mixed designs for even independent small houses, owners, engineers. He has published a book on concrete mixed design, and he passionately teaches concrete mixed design to many colleges, and he has presented many papers, webinars, seminars in many places across India. And in 1984 to 86, he worked as site engineer in Bhaktawar Singh Balakrishnan Company Private Limited, Bhilai, for construction of residential quarter for Sale Township, Bhilai. 86 to 98, served as executive engineer in NBCC, Government of India Enterprise, and executed prestigious projects like First Expressway between Ahmedabad and Vadodara, and a lot of other works in and around Hyderabad. 1998 to 2003, he worked in Gujarat Ambuja Cements as technical head of Kerala and Mangaluru. And here I want to specially mention that he was passionately teaching and building awareness about cements, all kinds of cements, and doing a lot of seminars. And throughout Kerala, he spread the knowledge about cements and concrete. This was a very important phase in his career, and many, I can say, thousands of people have benefited from his the knowledge sharing sessions that he has made and he has initiated actually. And then 2003 to 2005, he started as an entrepreneur, worked with the Design Right Lab as managing partner. 2005 to 2016, he worked as a general manager South in RMC Readymix India, a division of Prism Cement. Presently, he's the managing director of QCrete Readymix India Private Limited. We are honored, sir, today that you are here, and we are looking forward to your the experience, sharing experience, which can benefit many people. Apart from the list that we have told about, he's a member of Institute of Engineers. He's member of American Concrete Institute. He's also member of life member of Indian Concrete Institute, and played a key role in formation of Indian Concrete Institute Kochi chapter in 2011. And also he was chairman of the center. At present, governing council member of Indian Concrete Institute, and I can say he has contributed significantly to concrete technology in not only in Kerala region but all over India. With this, I welcome you, sir, and please start your lecture today. And I'm sure all the audience will benefit from you. Thanks a lot.
Thank you, Anil, for your compliments, and Kaushika for the introductions what you have given about me. Actually, thank you very much. Today will be today's session. Today's topic for today's session is why concrete is so humane. Actually, you might be finding it little peculiar about the topic what I selected. Actually, no, what happened my few years when I started my career, down around 10 years, I was working in a government organization, and I left and then joined Gujarat Ambuja Cement. My boss, my mentor, CM Dodi, once made a statement that what I thought that 10 years in the concrete field or building bridges and a lot of involved in concrete work, I thought I'd mastered that material called concrete. After joining Ambuja Cement, my boss or my mentor, my guru, gave a statement one day that married people only can understand concrete much better than those who are not married, actually. So I just married and just beginning my life with my life partner. So I was surprised actually what is more to learn about concrete actually. But down the line today, after 60 years, I'm already 60 years and still living my partner. I remember my boss words that yes, married people can only understand, married and living together for a long time can only understand the subject called concrete actually. So in this audience, who is bachelors, may take some time to understand this very good, very important material called concrete. Why? Because I am married and I had already experienced it. So I can say with conviction that yes, concrete can be understood. It's a very unique material and it takes a lot of time to understand it actually. So welcome, my dear friends, for this particular session. So I'll start just a journey of concrete actually. Might be thousands of years back actually. Man still built houses actually. And in those days, we did have material called concrete. The man used to go towards the hilly region. They used to select the best rock, cut it, and see to it that he and his family is staying safe in that particular caves what has been made for his family actually. So you can see that these caves are still existing till today actually, even after thousands of years actually, showing signs of durability actually. So durability is very important word actually, which shows how long your building can exist actually. So in those days, nowadays what is happening actually, we have a lot of civil engineers, consulting engineers, contractors, who's also civil engineers sometimes, and makes a house for you. What happens? At the most a year, at most after you pay the entire money, the guarantee ends there actually, or at the most 1 year. After 1 year, what happens even if a house leaks or built on a stormwater drain or some crack comes, it is for you or your head to be scratched actually. He's not bothered because he had already got the money actually. Now, where did this concrete took its birth? Some says it is during the Egyptians in the building of the pyramids. They had that discovered concrete, or with that Romans had built a lot of structures. Actually, you can see we can just connect it because Egypt the pyramids is still a mystery actually, whereas we can connect our concrete to the Roman Empire. So we can say that from the Roman empires, during the Roman Empire, the concrete took its birth actually. Now, in this particular structure, you can see everybody remembers, or the part of it still existing actually. In those days, people used to gather in this huge stadium, and a hungry lion is made to fight a prisoner. If the prisoner wins, he's set free. Otherwise, the lion will have a good breakfast actually. So that story goes like that actually. But it's not that one. These structures are part of it still existing. They had built a lot of jetties, lot of small structures, sea structures, which is still existing actually. Part of it, when it was tested, it was found that the concrete is still is alkaline actually. If the concrete is alkaline to this day, that means it is going to protect the steel inside the concrete. That means your pH of the concrete is around 12 to 13. It is alkaline. It's going to protect the steel inside the concrete. So even to till day, if the concrete remains alkaline, that means in those days itself they were building good, durable concrete actually. Now they were using lime mortar, lime with sand called lime mortar, and if you add aggregates to it, becomes concrete actually. So you can say the lime mortar is the elder sister of concrete. Or they had also used what we say is that new material called fly ash or PPC. We say that to make our concrete durable. But in those days, they had used volcanic ash. They had used volcanic ash as a material to be mixed with this to make the concrete durable. They had used horse blood to make it workable actually. They had used horse hair to make it fiber reinforced concrete. We nowadays call it as fiber reinforced concrete, or we add admixture to make our concrete workable actually. So all these things are not new. These were existing in those days when they were making the concrete actually. Now we had also built beautiful structures. I don't have to tell the story behind it, why this beautiful structure has come. I just wanted to highlight the workers who worked for this particular building this beautiful structure. What happened to the workers actually? They'll have to lose their hand for building a beautiful structures. In those days, what happened? Those days there was skilled workers were actually. It was a family tradition actually. That is a barbender or a carpenter. His grandfather used to be a grandfather. He'll pass on the skill set to his father, then to the son, to the grandson. So with every passing generation, they used to improve upon the skill on a particular trade. So we could build beautiful structures. Nowadays, what is happening? If you go, there is a lot of engineering colleges. I am very sorry, a lot of engineering colleges in all over India. But how many colleges are there to train the skill of the persons, like a masons coming out of a skill school where they are taught about the masonry or about the carpenter or about the carpentry? Very few actually. What happens is that these people join our industry as a helper actually, and you also join as a youngster. You also keep changing your jobs. These people also will go from one side to another side. one side he is an helper in the beginning. After might be 1 or 2 years, you meet him, you will see that a trowel in his hand, now he has become a mason. So might be after a few years, you'll find him as a labor contractor. So whatever the bad practices which is actually happening at the site gets transferred to these people, and that is being carried forward actually. That's why if you are given the entire money, I doubt whether we'll be able to build beautiful structures like this again in our country, because of the lack of experience, lack of skilled workers available actually. Now, as you know that there is a lot of flow towards the city, and now this is a Mumbai city. Mumbai was the first city to go vertically up. As you know that everybody was rushing to Mumbai for a place to stay. There is no other go but to go vertically high. And when they were going vertically high, when they had gone vertically high also, the quality of cement was not good. The concrete specification itself was M15 actually. And with those materials, with those type of quality of materials, we did the concrete. Now after 20 years or 30 years or 40 years down the line, we are bearing the brunt, because we can see lot of repair and rehabilitation work. If you go around Mumbai, you can find lot of repair and rehabilitation works, or sometimes it is being demolished also, because repair and rehabilitation becomes very costly. So it is happening there actually because of the poor quality of material availability, including cement, and even our specification was not ready to deal with that one actually. Now I'll be discussing few of these collapses which has taken place earlier, but nowadays we can see a lot of news coming up actually, a series of buildings getting collapsed. It's not very old building actually, might be 5 years or 10 years. You have been listening in the newspaper actually. So whenever any building collapses actually, like this particular building, like Poonam Chambers only, in 1980s, showing a picture of health there in the building, but it is not of the building, but it is of a company which was housed there actually. So whenever any building collapses, actually a lot of rumors. Earlier in 80s there was no mobile phone, so people used to call up and tell that such and such building has collapsed, and then rumors starts floating all around the town, and then slowly the municipality will wake up, and then they will institute a committee to go into the details why this particular building has collapsed actually. The committee goes, examines, detailed report is prepared, and then it is submitted to the municipality. But have anybody heard any report coming out actually? We'll never find out the reason why this particular building has collapsed actually. All the judicially, every report is being submitted, but it gathers just in the municipal office. Nobody bothers to reveal it actually. So what happens? Buildings after buildings keeps on collapsing, because the next building which is also prepared doesn't understand, and they create the same mistake, or some other mistake is created, and then the buildings collapses actually. Now recently also in Bengaluru, few buildings have collapsed actually. Some committee has been put into detail why it has collapsed actually. I think they are working on it. I hope at least that inquiry report will come out actually. Now this particular Poonam Chambers, this particular building had collapsed actually. Somebody said that it is a 20-year-old building, and it has collapsed because of the poor maintenance. Somebody said it is poor structural design, or somebody said that you can see a waterhead tank, overhead tank there. If somebody filled it with water, it collapsed. So all those rumors will start floating actually. Real reason for this particular building to collapse was on the 4th floor of this particular building. A company has taken the entire floor actually. He wanted to renovate his office actually. Now what happened? There were few columns running in between the building actually. So he didn't like the shape of the column. So he removed the cover, removed the stirrups, and then plastered with plaster of Paris. So what can happen? Nothing but at that on the 4th floor, when the entire configuration of reinforcement has been changed, nothing but the entire concrete building has to collapse. So this is one of the reasons why this particular building had collapsed. Now you can see here is another view of that one. Here, for about 4 or 5 people had died in this particular collapse, including one young architect who had come to visit her friend. It collapsed during that time, and it She also died in this particular collapse. Another building which I like to highlight is Shiv Chandan Andheri, Mumbai actually. Here we got a call from a distant from a friend who was staying opposite to this building built by the same contractor, because this building has already been declared and unsafe and it has already the verge of collapse actually. He was panically calling actually what to do. Now in this particular building, it's a 5-story building. On the ground floor, a bank was housed there actually. As usual in the morning when the bank employees came to work there's a creaking sound coming from the building actually. There was a creaking sound as if the building is made of a wooden structure actually. The employees refused to work here, and then they started complaining to the manager. As usual, the manager, no, they are all making bahana, you go back and work, but employees refused to work. They called the municipal office. They came down, they inspected the building and found that the building is unsafe for habitation. Once the building is declared unsafe for habitation, it is mandated that everybody should vacate this particular building because it can collapse anytime actually. Now here in this case, what happens is in this case the building, everybody vacated this particular building, including, because it's a high-story building, the neighborhood also has been asked to vacate actually. Here actually bakery fellow who has made enough dough thought that he will make the bread and move out. Poor he and his 5 workers died in this particular collapse actually. Now it is not necessary when the municipality has declared that building is unsafe for habitation that it will immediately collapse. It need not be. It may collapse after 1 month, or after 3 months, or after 6 months, or after 1 year, or may not collapse also. But it is not wise to stay in a house which has been declared unsafe for habitation actually. Now what happened subsequently, my friend's building was also removed. The foundation has been removed, and it was found that they had been, it has also been dismantled. That they found that few of the foundations were resting on sawdust actually. Now you know that in civil construction field that the boom time actually, whenever any boom time comes, everybody jumps into the real estate because there's a lot of money in that one. Everybody jumps into it actually. This particular area was a sawmill area actually, and then somebody has filled it up with red earth, and then a builder came and started building a 5-story, 6-story building without proper soil test actually, and then you end up in such type of collapses actually. So it's very important to understand how the foundations, whether the builder is going through the entire technical process of for building a particular 5-story or a 6-story buildings or a high multi-story buildings actually. Now this is another building which has collapsed is Gangaram building in Bengaluru. Here the basement and first floor, second floor, third floor was already functioning actually. As usual might be because of this building boom time, he also thought that he will make 4th, 5th and 6th building, 6th floor actually. So 4th and 5th floor has been casted. When the 6th floor was being casted actually, concrete was happening, the entire building collapsed here actually. Here, since it was a live building, the Gangaram's own bookstall also was there in the basement. Around 90 people was trapped here actually inside the building. Luckily, the phone calls were that time landlines were there. It was live. People calling, please come and help here and there. We are there, but outside situation you can see from building to building, it is entire area is filled with rubble, and nobody could approach our machineries. We are not that very prepared with machineries to go to do it fast evacuation. It's very difficult, and by the time it reached, the entire 90 people had died actually. So this here you can see the slab over slab is lying actually. So what has actually collapsed here? The supporting system has actually collapsed actually. You can see the slab is lying over slab actually. The entire supporting system has collapsed actually. So when we do a supervision of a building, most of the time for slab, everybody is there on the top of the slab actually, supervising it. But for a column, none of them is there. Now you can see this young gentleman, young engineer, after passing out of the college, he has made a very beautiful bridge. He thought that he'll show his grandson how beautiful bridge he has made actually. Poor fellow, before he could get married, the bridge collapsed actually. So such type of things has also happened. You can see it's a Mangaluru river bridge collapse. Here one traffic was moving. One fine day, you can see the bridge collapsed. And reasons, you can see that again, pre-stressing cables. It is a coastal area. The bridge is running to the coastal area. Highly extreme weather condition. Actually, extreme weather conditions. We have to have for higher grade of concrete, or we should go in for a blended this one to avoid the corrosion effect. Actually, you can see the tendons are corroded, and due to it has given way, it just collapsed. Actually. Now let us understand why failures occur. Actually, there are 4 reasons to it. Actually, ignorance, greed, carelessness, and negligence are the 4 reasons why the collapses take place. Like ignorance, if you are an engineering student and during your college itself, you should attend various seminars, various people who are with experience, they come and speak. That time we don't give that much importance actually, but to remove your ignorance, that is the best way to, they give it as a capsule actually. So go through that one, work for it actually, and then you can remove a lot of ignorance part after you come out of the college and start working in the field actually. Next is greed, which I did not explain because it is synonymous with the civil engineering, and due to which there is a reasons why some of the collapses taking place actually. Another is carelessness, which I had already touched earlier. Like when a 200 cubic meter slab happens actually, all the contractor is interested because he can submit the bill of 200 cubic meter. So he is there working with the workers and doing a lot of alla. Same thing with the site engineer, he can show the progress, the architect, the structural engineer, everybody is there on the top of the slab, checking each and every point before the concrete starts actually. So it is well supervised. But what happened to the poor column which is supporting this slab? That is 200 cubic meter. This is only 0.2 cubic meter. And for that 0.2 cubic meter actually, what happens is that as a site engineer, you say that it's a small cubic meter of concrete. You leave to a young engineer at site. You go out of the site. Then young engineer, he must have given some appointment to his girlfriend or boyfriend. As soon as you leave, he also leaves, leaving it to the head mason. Then the head mason thinks that he has been doing concrete all his life. What is there in that one? He leaves it to the unskilled worker to do that work. With his understanding of water cement ratio, he will mix according to his understanding, make it more workable with adding more water, and that concrete is being done for this 0.2 or 0.5 cubic meter of column concrete, which is supporting the entire slab. So that carelessness actually leads to collapses actually. Next is negligence actually. Now for you had made a house actually, and you suppose you purchase a new car, and the car dealer says that after every 5,000 kilometers you have to bring it to the car shop for maintenance. You do it daily, without fail you'll go there and do it actually. But for a house, you have made your own residence house actually. Where is the regular maintenance take place? Unless until you see some part of concrete or some dampness comes and the water leaks, then only you start thinking about doing something actually. Though no regular maintenance takes place. So that negligence can lead to collapses actually. So some of you understood, some of you have discussed how to solve the concrete problem. Some of you haven't actually. So shall I proceed actually with some of the elementary things, what we should look into the for producing quality concrete. So the first step in concrete making is to make a good workable concrete. It is just like sending your child to a good school, a good college, teaching them good manners, good education you are giving. You are molding your young kid into a good human being. Same thing, you should know how to mold the concrete actually. You should know how to mold your concrete. How can you mold the good it is by giving good workability. Good workability means less of entrapped air inside the concrete actually. Less of entrapped air inside the concrete. So it will be easily able to place it, compact it, finish it actually. So that is the purpose we have. Workability and water cement ratio are two separate aspects. Even with low water cement ratio, you can make a high workable concrete. Workability generally depends on the type of work actually. Suppose if you are doing a road concrete, you require low workable concrete. You are going for a house work, slab work, you require medium workability. If you go for a piling work, you require high workable concrete. So it all depends on the type of work. There is no connection with water cement ratio. Now, if you see here, this concrete, there is lot of entrapped air in the concrete actually. You can see a lot of the concrete surface is not very smooth. There is workability is very low. It is very difficult to place the concrete, compact it and finish it. It's just like, if I am working under a boss who doesn't understand you, then either you should leave the organization, or you if you find a newspaper cutting, you cut it and put it on the boss table. So see, he sees and leaves the organization. So there are two alternatives only. If you are making concrete in this fashion, there is only two alternatives. Either you stop making concrete, or you'll be making miserable concrete throughout your lifetime actually. Now, these are all inborn defects in concrete. You can see if you are making a concrete with low workability, you will end up with segregation, honeycomb. You can see a lot of segregation. It's a non-cohesive mix. Watery lean concrete will all leads to this honeycomb segregation of segregated concrete actually. You can see here on the photo. Again, inborn defects in concrete. Now you are done the concrete, next day you come to the site, you see the steel rods are being exposed. It is not minor concrete, it's a major, this one actually. Now what you'll do, you'll call the mason, natural tendency, you'll call the mason and ask him to plaster it actually, so that before the client engineer comes, you can hide it actually. But that is just putting a powder on your face actually. Nothing is going to happen. In this aggressive environment, all the enemies of concrete will enter this concrete and it will attack the steel in that portion. That is the weakest portion where the honeycomb and segregation portion is the weakest portion. All this water, moisture, along with that chlorides also will enter and it will attack the steel. It will corrode the steel and it becomes the weakest portion actually. So inborn defects in concrete, just to compare with the human beings, that careless in design and production often results from bad practices, poor specification, lack of knowledge. This results in deterioration of concrete and eventually repairs actually. Similarly, for a human being who is also careless about his health or due to wrong habits, lands up with serious health problems, need medication or surgery actually. So in same cases, he may land up losing his life. So likewise, a structure may also even collapse actually. So we have to, right from the design to the production to the selection of the material to the implementation at site and the specifications, every part should be taken care to produce a good durable concrete actually. Now you can see here, next property of concrete is cohesiveness actually. This man, if you see in this picture, he is very good in his job, very good actually, he's excellent in his job. And his wife, she's also very good actually. In her own job, she's also good. But in human terms, if they cannot get together, we call it as poor understanding. It leads to separation. So same thing in concrete. Even though we have the best materials, but if you don't know how to make a cohesive concrete, it can lead to segregation actually. Now you can see here the property. You've got a good workable concrete. Should be workable concrete, and you can see the entire surface is coated with cement paste. That means the entire surface is coated with cement paste. That shows the concrete is very cohesive actually. Another test is that you take a ball of that concrete, throw it up in the air, and it comes back as ball. That mix is a cohesive mix actually. So you can use it at site. If you don't have a slump cone and if you want to check whether your mix is cohesive, you can go for a fast check for that product. Otherwise, it is generally advised to have slump cone to have a good measure of the workability and the cohesiveness. Now, concrete, like human being, is born by blending of materials. Cement, water is considered a genes of concrete actually. Concrete structurally generally conceived by architect, and the engineer helps to become the reality actually. Now, what is this concrete actually? If you see the different parts of concrete, cement comes from stone actually. Coarse aggregate, again, it is stone, a part of stones actually. And if you see the sand, it is also a disintegrated part of stone only. So what you do, just like if you go to a shop to buy a fan, you don't get it as a fan, you get different parts. You bring it home, attach it, and then hang it as fan. Same way, you are making an artificial stone as closest to the natural stone actually. So all these parts we are bringing to a certain location actually, and then mixing it with water and putting it as on the top of the slab as natural stone actually, to make an artificial stone actually. So when you are making this one, the coarser aggregates will form the matrix actually. The gap into that should be filled in by the smaller aggregates. The gap into that should be filled in by the coarser sand. The gap into that should be filled in by the fine sand, and the entire matrix should be held by the cement paste, which also fills into the gap of these where the fine sands are there into the gap. It fills up actually. So the more the compact, the more the denser your concrete is, the more closer to the natural stone actually. Even if you are using fly ash, which is 100 times finer than cement, or if you are using microsilica, which is 1000 times finer than cement actually. So all these are filling the gaps, voids, and making your concrete stronger actually and denser actually. Now you can see beautiful structures has been made, and you can see nowadays we can see all the metros. In the metros, all the good pillars are there, where workable and cohesive concrete has been used to make beautiful structures. No plastering is being done. All the concrete is exposed. You cannot find a single where any place where you have the honeycomb or segregated concrete has been used actually. Now, any shape you see, your eyes pops out actually in the human being. Same thing for concrete, your shape, the correct shape, like it should be proper shape. The shuttering plays a very important role. Like suppose if you are inviting me for a dinner, what you do is that you go to the shop, buy the best quality material for preparing the food actually. Your wife prepares a beautiful, nice food also. But that same food is also served in a nice plate actually. So food and plate both should be good. Then only you are ending up with a nice dinner actually. So same way, concrete. If your concrete should be good, your shuttering also should be excellent. Then only you'll be ending up with good concrete actually. So shuttering plays a very important role in concrete making. Now you can see a good formwork designed by a engineer who knows about the shuttering design, and then he prepares a uh, formwork into the designs it, and then he gives it to the carpenter to scale it at site. Normally, what happens is that it is not taken in the colleges. We are not aware of a formwork design. We depend on the carpenters who design for us. Then what checking we can do? We cannot do any checking. So we are depending solely on the carpenters. He decides what is the thickness of the plywood or the type of support required or the rafters thickness. All these things he only decides. We are only a mere spectator in this particular region. So no check happens. Now, if you are a supervisor in this particular building for doing the concreting, it is better that you can pray to God, because if the concrete remains on the top, you're lucky actually. If it comes down, you're unlucky. So you can see here, none of the props are kept vertical actually. You tell that contractor, you do it, sir, you told only 50 props to be there, put 100 props. But what is the use of having this 100 props all in inclined level actually? None of them will carry the load. One small area is enough to bring the entire slab down actually. Now here also you can say a non-engineer double formwork happens actually. Double shuttering is there happening, and this also leads to collapses. Now, like Ludhiana warehouses, where a contractor was awarded a work which he was used to doing only single-story building. He was awarded a warehouse where the shuttering height was double, and he did the shuttering, allowed 3 carpenters to stay at the bottom to look if anything happens. Please inform me. Before they could inform, the entire building, the entire warehouse slab collapsed actually, taking the life of these 3 young carpenters who was below the slab. This is another view of that one. Now, anything which is beautiful, you all appreciate it, just like London Bridge, you all appreciate it. Same thing. Concrete also, we have beautiful structures we can make. You can see a bus shade, beautiful bus shade actually has been prepared with concrete, versatile material actually. Or you can see the hanging, the swinging slab, it is called in Lisbon Expo. You can see the closer view of that one. The slab which swings actually, beautiful structure. Now you can see this Nehru Science Center, Worli, another beautiful structure which we had made actually. Lotus Temple in New Delhi. You can see here the cladding, the structure to make it look white. They are cladded with white marble actually. The structure is excellent, but to make it look white, we are cladded with white marble actually. Whereas this is also Baha'i temple, another Baha'i temple in Chicago. Chicago we have. It is a concrete made to look white. It is no cladding is being done actually. As the moonlight falls on it, it emits light. It's also called Temple of Light actually. So beautiful structure here. Now this is not an architect has given a design to this particular building. This is cracks which has happened. It's a building near to the coastal area, near to Cochin, and you can see the lot of corrosion, and due to which cracks has happened. It has been filled with crack fillers actually. Now you can see this particular structure in Mumbai, and now it is completely, they had removed it because what happened was that it was cladded with white, it was cladded with marble, and if you park your car below this structure, by the time you come back, one of the marble must have fallen down. It must be falling on your car, and it will go into different shape actually. So this particular building, because of the dangers, they had completely removed it actually. So good strength, which all engineers, we all like. As engineers, we are very happy to have the strength parameters. We look for it now. Even nowadays, we have ladies showing the strength in the WWF actually. Like in Petronas Tower, the second tallest tower in the world, actually, you can say that it is in the construction they had used M80 actually, 80 megapascal concrete has been used. Now here the beauty was that when they were making the for M80, they are not already used only ordinary Portland cement. They had used a combination of fly ash and OPC called QCrete to produce M80 concrete. And during the production of this concrete, it is surprising that we say that M80, the strength has gone up to M100 actually. Whereas in our country, we designed for M20 and we struggle to reach M20 concrete actually. Now, the concrete, this man sitting under the concrete cannot keep secrets of bad work actually. You tell something to your wife, and after distant time, you can hear it from your relative what you are told and what you are not told comes from them actually. So just like that, concrete also cannot keep leaks. They cannot keep secrets of bad work. Actually. This man sitting under the umbrella, he is showing the weather forecast. It's heavy rain, but he need not be told that because he's already sitting with an umbrella inside the house actually. Now what happens is that after a few years of construction, you can see some dampness coming on the roof. You can see the fan hanging there right now. After a few years, you don't do any repair work. What happens? You don't do any repair work. What happens is that now the fan is not there. Concrete along with the fan comes down one fine morning. The weakest portion. So that will lead to high maintenance cost. It is just like marrying a person with expensive taste actually. You can see here, this man his hand is loaded, his mind is worried, his pocket is empty actually. The house owner, which is having a house, having lot of maintenance coming, his position also is in this same condition. His mind is always worried and his pocket is always empty actually, because he keeps on spending, repairing it, and next monsoon or after a few years, it comes back in a bigger way actually, and he keeps on. So maintenance costs are very high actually. Now you can see here, it's a cracked beam, hanging sword on your head actually. You cannot sleep under it actually unless until it is properly and technically consulted and repaired actually. Now you cannot sit under the beam and leave the repairs to God actually. It has to be done technically correct way it has to be repaired, or it may one day come down actually. So that poor durability of what we are constructing actually might be, we say that we have to build a structure which should last for 100 years. Some buildings may last for 10 years or 15 years or 20 years. It's a poor durability, just like losing a life partner very early in life actually, short life. That is, sometimes if you don't build your structure properly, it also leads to collapse early age. So a holistic approach to durability of reinforced concrete lies on 4 strong pillars actually. I always say it's structural design and detailing. Then we have the material properties. We should understand what type of materials we are using. Then we have this mixed proportions. You have to go in for a proper mix designs. Then mixing, placing, consolidating, and curing. If you follow all these steps religiously, we should end up with a good durable concrete actually. Now you can see here one of the particular honeycomb in a column beam junction actually. It's a column beam junction, and you can see the contractor has done a good job up to the junction. He has done a good job, but in this column beam junction, he had ended with a honeycomb and segregated concrete actually. So somebody has asked, what is the reason? Who is responsible for this one? Everybody has told that it's contractor, or somebody said it's an engineer at site who is responsible. But I say it is basically poor detailing, or maybe this particular structure has failed in the structural office itself actually. Because the structural engineer has to, it is very easy to draw few lines and dots and you hand over the drawing to the site engineer. And when he's trying to start to scale the particular structure at site, he didn't find any gap for a vibrator to go inside or for the concrete to go inside, and ending up with in the most important structure in a honeycomb and structural. So each and every details right from the detailing stage itself, everything should be properly marked from where the concrete has to go, from where the vibrator should go in these important structures actually. Then only right from detailing stage to the what I said is compacting finishing, we have to be looking into it to get a durable concrete actually. Now we have enemies of concrete, just 4 enemies. This I'll be just covering it in brief. Like we have 4 enemies of concrete. Water is the main source for making concrete, but it becomes enemy number 1 after the concrete is made actually. So along with the water, chlorides also enters, due to which again the concrete can deteriorate. Others carbon dioxide and sulfates. So water or moisture actually. Suppose if you are making a house in Bengaluru and the concrete may last, might be for 20, 25, 30 or good, same M20 concrete, and same concrete if you are making it in coastal area like Cochin, it may last only for 10 years or 5 years actually. Why? Because there are a lot of chlorides in the atmosphere actually, and the chlorides also along with the water enters through the capillary pores inside the concrete, and it attacks the steel actually, and rusting of steel take place. Now you can see here it is a small this one. Human beings actually follow love-hate love relation. That is, in the young age we love, we find somebody good partner we love. Then after marriage there is an hate period. Then in the old age we love, we come back again. That's a love. So love-hate relation. And human beings, when they make concrete, they follow the same pattern actually. Love-hate love relation actually. Like when the concrete is made, they love to add more water. And when after the concrete is made, when they require curing, we hate to add water into that one. And after that, the structure is allowed into the all aggressive environment actually. Whereas concrete follows love-hate relation. That is, at the time of making the concrete, they hate to add water. They love water after the concrete is made. That is, curing is required after the concrete is done. They love, and then hate aggressive environment actually. So that is the issue when we are making concrete. So concrete also cannot take tensions like human beings actually. So we cannot take excessive tension and often crack up like concrete. Now you can see here relation between the capillary pores which get blocked. Suppose if you are making a concrete with 20 liters per bag of concrete, the capillary pores in concrete will get blocked in 3 days time. Suppose if we are making the same concrete with 35 liters per bag, the capillary pores will get over a 1 year time to get blocked, or it may not get blocked actually. So what happens in 1 year time? We are having 2 monsoons actually, and water has already entered your concrete. It is just like blood traveling through the capillary pores in your body. The water travels through the concrete body into it, and it may not show it immediately at the bottom. It keeps on traveling, and it will, some unhydrated cement will be there. It starts cracking up actually. Then the cracks bit forms again. Next month moisture it enters, and slowly it reaches the steel. So water cement ratio, importance of water cement ratio is 0.35. Your water cement ratio, your coefficient of permeability is 1.05. As soon as it is increased to 0.5, it increases 10 times. As soon as it increases to 0.65, it increases 1,000 times actually. So while preparing concrete, we have to be very, very careful with our water cement ratio actually. Now you can see here the cracks which is getting induced. As I told you, slowly the capillary pores gets joined to the water, moisture enters, along the moisture, chlorides also enters. It comes, it touches the steel, chlorides also enters, it touches the steel, a particular portion, then rusting starts to take place actually. So this is a simple electrochemical process which takes place here. That is, you can see here, as soon as the moisture touches along with the chlorides, a particular steel ring, so that portion will act as anode, and rest of the steel will act as cathode. The concrete will act like an electrolyte. Ferrous gets converted into ferrous oxide and hydroxide, and slowly the rusting takes place. And you can see the size of steel increases 6 to 6.5 times actually. So due to which the cover portion, which is the weakest portion, which comes down. You can see here, this is a reaction which takes place. This is the size which increases volume. You can see around 6.5 times it is increasing. The steel size is increasing 6.5 times, due to which the cover portion which comes down actually, which is the weakest portion in concrete actually. So what is the remedy is, you have to make a concrete with low water cement ratio, or you can make concrete with PPC or PSC cement, or you can use ordinary Portland cement. You can add externally fly ash, GGBS or microsilica to make your concrete durable actually. I will come to it, that one you can see here, one particular structure, handrail, you can see through the capillary pores the moisture has entered, and then unhydrated cement is there, or that comes out as leaching actually. White patches which is seen, it is all unhydrated cement particles inside the concrete body, which reacts with this moisture and comes out, leaving a bigger capillary pores inside the concrete body. Only for the next time when the moisture enters, the crack widens actually. It reaches the steel. Now you can see here small. If you are making a concrete with ordinary Portland cement, if you are making a ordinary Portland cement and with water, you get a CSS gel. We feel that the concrete what we have made is very strong actually. Here actually the CSS gel what is formed is around up to 70%. Now, due to which what happened is that we have this excess lime which leaches out, makes your structure weaker actually. Weaker. Actually, over a period of time, it leaches out and then it makes the structure weak actually. So remedy is that actually you can add fly ash. This excess lime now will start reacting with fly ash and closes the capillary pores and makes your concrete denser actually. And leaving, what happens is that this is a secondary reaction which takes place. It's a secondary reaction which takes place. And what happens is that now the CSS gel, which earlier was only up to 70%, goes up to 95%. 95% of the CSS gel, if it is formed, then very less is this portlandite is available, which can come out actually and make your concrete more stronger and durable actually. Either fly ash or GGBS actually. Secondary reaction makes your concrete capillary pores, it gets closer, make your concrete more denser actually. Now the third enemy of concrete is carbon dioxide. As I told you earlier, pH of concrete is around 12 to 13 actually. Over a period of time, what happened? All the concrete which is protruding outside, just like balconies, which is protruding outside, there is a lot of carbon dioxide level which is increasing day by day actually. A lot of pollution is increasing in the city actually. So what happens is there's a carbonic acid which forms on the concrete surface, which reduces the pH. It reduces and goes beyond the cover portion actually. It reduces the pH to around, comes to 8. Then what happens is that concrete, the steel gets exposed and the corrosion starts taking place. The remedy is that we have to go in for higher and higher strength of concrete actually. Now you can see here, earlier I had shown all the balconies which is protruding outside. This is basically carbonic action which has taken place. Carbonic acid which was falling on the concrete surface, which has reduced the pH. That steel is exposed, and then steel is now exposed due to which, because cover is only 20 mm, 15 mm, 20 mm we are providing, and it exposes beyond that one actually. It exceeds that one. You can see here, this is estimated 20 years carbonic depths for different grades of concrete. Estimated 20-year depth is for a concrete which is produced 58 Newton per m square. The estimated depth is after 20 years was only found to be 6 mm. Whereas for M20 concrete, after 20 years, the estimated depth is around 33 mm actually. So it has gone beyond the cover portion actually, leaving your steel vulnerable for corrosion actually. So we have to go in for higher and higher strength of concrete to avoid the carbonic action section. The last enemy of concrete is sulfates actually. Now sulfates, what we say is that in sulfate resistant cement has to be used. There are 4 phases in concrete. We have C2S, C3S, C3A, C4AF actually. In this, C3A is the most reactive element actually. It is in ordinary Portland cement, it is around 8% it is there actually. So what happens is that this C3A combines with sulfates to form a compound called ettringite actually. And this gets into the concrete. It has expansive nature. It starts cracking the concrete actually. So what is the remedy? You have to use sulfate resistant cement actually. Sulfate cement is nothing but reducing the C3A to around, minimizing it, so that less of C3A, then what happens? The reaction will not take place. Your concrete will be safe actually. But what happens is when you are reducing the C3A, if it's suppose in a coastal area like Kerala, we have for 100 parts per million sulfates, there are 10,000 parts per million chlorides present here actually. So if you are reducing the C3A, actually C3A will react with what it does, it repels the chlorides from entering the concrete actually. So if you reduce the C3A to minimize it, all the chlorides can enter your concrete and it can corrode your steel reinforcement actually. So better to go in, what we suggest is that you should go in for a blended cement. GGBS is the best actually. You can go for ordinary Portland cement with GGBS actually. Now for a sewerage outfall project in Mumbai, which was taken 10 kilometers inside the sea, concrete tunnel, when they made the segments, they made M40 concrete with 70% GGBS and 30% ordinary Portland cement actually. With that, they have produced M40 concrete, and that was the best one because the sewage is having both chlorides and sulfates, and the seawater on the external surface, it is all full of chlorides actually. Chlorides and sulfates is there, so it was the best to resist the attack from both chlorides and sulfates actually. Now you can see here chloride diffusions in various types of cement paste having constant water cement ratio of 0.5 at 25 degrees centigrade. You can see the best performance we got it was slag cement, that is 35% OPC and 65% slag was given the best performance of 0.41. Second best was Pozzolana cement, 70% OPC and 30% fly ash. OPC, this one at sulfate resistant, is the least preferred in the chloride environment actually. So we can go in for the blended cement, or you can blend it externally. Ordinary Portland cement, you can have it. You can have fly ash or slag in another silo, do the mixed design and blend it externally and do the quantity. So this is one particular concrete box type structures which was done for Tata Electric company actually. It's a 2000 cubic meter, the 2000 cubic meter concrete. It was a box type structure. It has to be sunk around 15 kilometers inside the sea actually. Now you can see it is being towed by a boat. So concrete is made waterproof actually with proper study of material, proper concrete with proper expansion construction joint, we can make your concrete waterproof actually, which can be towed. Otherwise, what will happen? You have to make a long jetty up to 15 kilometers, push it and pull it and up to that location and then sunk it actually. So here it is easily being towed there. That shows the concrete can be made waterproof actually. Now, for all this to happen, for all this thing to done, we have to do our homework properly. You cannot be sluggish actually. You have to act in the field. You have to be very, very precise in doing each and every steps which I touched upon actually to get a good concrete. Otherwise, what will happen is that you will end up with such type of structures. This is not a petrol pump actually. This is a house. House owner has paid a good amount of money to the architect to make a beautiful structure. But poor fellow, he couldn't sleep inside the house because all the water was falling inside the house rather than outside. So he got so much fed up that he said not only in the house, in the entire compound, no water should fall. So the entire area he has put up a sheet actually. So this is not good for a civil engineering point of view actually. We have to also get up and act and see that all the concrete what you're making with which serves the purpose actually. So we have to bridge the gap. We have to bridge the gap actually. It should we have good theoretical knowledge. A lot of effort is required to make beautiful structures actually. So let us bridge the gap and see that we build very beautiful structures which give a long life, long lasting designed life. What we are designing it, that life we should get to the concrete. So concrete is just like human being. It needs care in childhood, good supervision in youth, and sufficient maintenance in old age actually. So with all these things taken care, you can have a long life with your life partner actually. So thank you. Concrete is so human, isn't it? So let us have romance with concrete. Thank you. And also thanks to my mentor and guru CM Dodi for his support and guidance. Thank you ICA Mangaluru participants for your presence and good wishes. Thank you very much. Thank you.
Good evening. Thank you, Shelly sir. Thanks for a wonderful lecture. Some question answers session will be taken. I hope some questions will be there, which will be asked actually. Anjali madam, can you ask the questions?
Sir, so far we have not received any questions.
Okay. No problem. Anything they can put it in the web mail, no? That's one.
Yes, sir.
Thank you all, audience. Any question is there, you can send to shelly@QCreteIndia.com or ask Dr. Q website www.QCreteIndia.com. In this evening, we are thankful on behalf of QCrete Readymix India Private Limited for all of you to have come and attended. And now over to Anil Balika sir. Anil Balika sir. Yeah. Hello. Hello. Anil Balika sir. Hello, Mr. Anil Balika sir. Anjali madam, Anil Balika sir is online. Okay. Hello. Once again, I thank all the audience for attending this webinar on behalf of QCrete Readymix. We are thankful to all of you. And Shelly sir, the lecture was wonderful. You have dealt on all the aspects which have to be taken care, and the important points where the durability, how it has to be taken care, what are the important points have been dealt in detail. We are thankful to you, and I hope the audience have benefited from this. And once again, on this evening, on behalf of QCrete Remix India Private Limited, we thank all of you, and we expect you to attend our next webinar too. Once again, thank you, Shelly Fernandez sir. Thank you.